Welcome to challenge number 52. And this time we have something about optimization. It's a very interesting problem to solve. We have optimization tool in Alteryx in the prescriptive. We're going to use that. There's another way to solve. We can use a location optimizer to solve that as well. So it's like a packing problem. The idea is we have some kind. Let me look at the input. We have some box. So we have 5 boxes. Each have some kind of weight and a certain cost. So you try to pack different number of boxes with some kind of condition. The aim is you try to maximize amount of money. Uh, so you try to maximize dollar part, but you also want to make sure you are kept under the 15 kilo condition. So you have a linear combination with constraint. So that's a linear program or linear optimization, how you want to call it. The challenge you're looking for is in different cases. So if you pick one box, what's the best choice? 2 box. Because I think one box is everything is below 15 kilo. Then you maximize that. You should probably pick the last one. That's part one. Yeah, if you pick the last one, that will give you four. That's 4 kilo, but it'll give you $10. That's optimized, the best choice. If you have 2 box, you have some kind of combinations. You try to looking through. And the idea is you try to go through with a different number of boxes. So for us, we're looking to solve in different scenario for 1 box, 2 box, etc. What's the best combination? Detail 2, try to handle, yeah, for each number box, what's the best, what's the output, you should go for the box. That's it. There's 2 parts of data input. You can see they also implement the location. So that's location optimizer. We're going to probably do a second part of the video to show how that's done. For first part, let's handle as a linear programming solution instead. The way I would go for it, let me just turn to rows first. We're looking for up to 4 rows, like a dummy, because that's how many boxes we're gonna handle. Now to be able to do it, let's just open a separate stage for a macro input. You can see the optimization tool on its own has a lot of input. You can set in, depends on how you want to set up. Again, that's a separate video. We can probably do. For us, because the question is reasonably straightforward, so I think I'm gonna probably just manually. Let me see. Yeah, I'm going on the top rather than select from your input file. I'm going to just do select manual input. To the manual input, let me just drag this in. I roll this up. Down on top, that's the way to usually the way the problem is framed. You have the objective function. So either you try to maximize or you try to minimize something. In this case, we try to maximize the dollar amount. Then you have the corresponding coefficient for 1, 2, etc. for each variable. We have 5 choices, so that's why from x1 up to x5. The second line is subject to, that's your condition, that's your bound constraint. What you have various kilogram combinations. You are capped at 15 kilos. That's what the last condition is. The last one, particularly when you're learning it, it's always important teacher to remind you to remember this. It's actually needed for the problem. Otherwise, it becomes unbounded. First of all, most often you have physical object, so it's natural. It's a natural boundary. It's always positive number. You don't usually have negative, in a sense. You can't have negative number of boxes. Number next, technically, no negative amount of money is in your assets. You cannot borrow like negative amount. So you try to keep positive. The second thing, because for us, we try to do is box. So we have bound a boundary. We're going to just probably pick 1 box each. The question didn't, I think the question said you can only pick 1 box. Did it say anything about repeating box? Yeah, you are only allowed to pick 1 box. So the maximum for each you can pick is 1. Otherwise, you will have a different condition. You can just pick your box 5 times if you need. So that's a general layout for the challenge. So we can just start to copy those ish into the menu input. So on top, we can see we're looking for as a list of the variables. Let me just copy my list, I guess. First thing, you have a list. So I have 5 variables in there. Objective. So the objective will try to maximize our things. I wrote somewhere already. So the constraint should be yeah, constraint. Did I let me do the plus? I think they are not happy about objective fund constraint the fund boundary. So for us, we are actually solving integer questions. So we just have they can actually do binary. It's fun. Integer allow you to choose anything up to infinity. If you have continuous, you choose continuous. Then in that case, you say, oh, I can select half, 0 0.5, 0.27. So usually that's a 3. Let's just put a constraint that. Let's show the browser. I think we need one more constraint, the natural boundary constraint. Now, this is total weight constraint. We do actually need another constraint, which is, I forgot the type. Because we can only choose one box each. Let's x5 equal to, let's say, in the first case, because each axis is a dummy in the binary, this dummy, 0, 1. If equal to 1, that means overall you can choose one box. If it's equal to 2, that means you can choose 2 boxes. See, the coefficient technically in front of the axis is 1, that means you can choose one each. And that, let's just give a row. Usually, it does take some time to the engine to spin up, but the data set is small enough, should be able to get some results. Let's have a look what we're going to get. So the idea is the only thing, the whole setup we need to modify is the number of boxes. Oh, it does. Objective, let's click on interactive. Hopefully it doesn't crash. While it's loading, at least we can see for, I feel like I need to change the input. But at least for the optimization tool, you do have the chance to pass out the results you need. Go to the downstrings. I think I set up incorrectly. You're not getting errors. Da, da, da. Mhm. Yeah, input for x1, for x2. I think I need to do this better. I don't know how to do this. Yeah, it should have a space. Let me just pause the video to have a look at the setup. Okay, we'll come back. The first thing I noticed, I forgot to put the enter, the plus E, so that natural boundary on the box number. Because we're trying to maximize our workflow, then you have a toggle to go maximize or minimize. Salvage should be fine, keep everything else default. We have just linear programming. Just run workflow again. So I think it took about 15 seconds-ish to run the workflow. Later, we're going to change. The only thing that matters is different box number. It's just change the second constraint, x1 plus x2 plus x3, until the last one you get is equal to 1 box, 2 box, etc. So, objective, does that render? File path screen. Oh, I probably need to change my file path something. But nevertheless, we can zoom in here. So try to read this a bit. So the interface tool will give a better, easy way to read where the results is. But that said, we can still see what we come out output is may not be the easiest to. Let me just zoom in, capture the right one. So for us, the variable is the one we actually care. So this says if you have one box, that's what I did, is you should choose X5, the value. You choose one, you choose one box, X5. What's the coefficient of X5? That's a $10 box. So the objective you met is in total 10. So for one box, you did the best job. We can modify things a bit. For example, rather than constraint 1, we need to change the value to constraint 2. I should copy this in first. Let me just copy this one first. Let's just give a test to say for the second part, we try to solve rather than have one box, we try to go for two boxes. What's the best answer this thing can give us? In practice, you linear programming is a lot more complicated, and even if for a linear problem, depends on boundary conditions. You have a different solver, and performance matters. At the moment, for us, we have 5 variables. Real life case, you may have a lot more variables. That will take a significant more time. So, for two boxes, it tells us we hit an objective with value of 12. We choose box 3 and box 5. Let's look at the answers. What we get. So box 3 is the 2 kilo and the 4 kilo. So blah 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 F for that may not be the easiest to see. This first row, the 4-10 combination, that's a box 5. The second row, 2-2 combination, that's box 3. So we're getting what we desired results. Da, da, da. That's done. Because we want to implement for each of those, what you could do is you can feed in your almost drag your macro. So you can drag your optimizing to 4 times in the workflow. But for us, because we know you technically can create as many combination you want, let's just create a batch macro instead. So the only thing we need to change is that the box number condition. Your whole list of values change. So for us, it's the constraint we want to change. So it's only the second constraint we need to change. So that's the email of VC. Let me just zoom in. So we try to change this number too. That's the boundary, the quantity boundary. That's done. Then I think the next thing is to match the final answer they're looking for. They are looking for kilo, dollar, and the number of items. So they want how many boxes. Let's call this in int them. So let's get default to the workflow running it. We can update our value in the formula tool. So the value is 2. Let's update the value to. Wait, what's the point? Expression value. Yeah, I think it's an expression value too. I want to update. For the outputs, let's feed in this guy. Let's feed the S output. Then we have a macro output. Oh, that's probably shouldn't let that run. So let's wait for another 10 seconds. So with this thing, you can dynamically change the conditions. There's different ways you can input. As you can see, the input anchor. We can input objective function as a formula, as a table input. Your boundary conditions, your natural boundary, your subject to, so your natural constraints and your natural constraint regarding x. You can input separately. Okay, that's fine. That's what we'll output. Let's save that as some location. I'm going to just go desktop. Input, map cleaning, it's only work 52. the batch. So let's select row count. That's the control parameter that's updated. Right, all row. Because we have a full iteration to run, I'll pause the video and come back for it. Okay, just set a note. Just move cleaning. Got an error. I don't know why. I think probably date type maybe. Uh, I modified the condition, just changed to a variable. The variable doesn't exist, but I feel like the action tool probably set up incorrectly. Previously was using two. Now I'm just changing that to a variable. Yeah. It won't run in the macro itself because the variable is not defined, but the macro will help you to feed and replace the corresponding terms. This is actually a good chance to actually set up global environment. You can use that to control things. That's probably a better design. Anyway, with that change, we'll run the workflow. It's about take 20 seconds. We'll get an output, so you can see each is an objective pair. When we get the value, it's a 1. For each box, we get 10, 12, 13, 14. That's the optimized value, and then the corresponding box number. So for the last one, you should pick the last 4 boxes. So we get 10. Oh, they're not in grouping, but let's go this one. Yeah, 10, 12, 13, 14 is the best choice. The last box you try to pick is 2241 for the kilo. So so you have a 2241, so box 2 up to box 5. That's the best choice. And that is how you use optimization to solve this problem. Of course, you could implement your own some kind of iterative macro for each number, but that will be very long and a convoluted way of doing so. So optimization definitely solve it. Next video, we're going to have location optimizer to use that as well. Thanks for watching.